Alright class, so as I explained in my first day of class, that when we do have class canceled, I go ahead and actually have our lecture just via a video instead, just to make sure we stay on track and I don't end up having to cram a whole bunch of information in too quickly. So we are going to go ahead and cover what we needed to in the notes today. I'm going to actually start by kind of refreshing our minds on where we ended last time. So we were working with that 68, 95, 99.7% rule. We had gotten through 2 examples so far. So kind of recapping those real quick. So we had this mean of 75 points, a standard deviation of 8 points, and then this is just shorthand notation for saying exactly what's in there. So Y is just the number of points that Kentucky scores. That little squiggly means distributed. The N means normal, so that it has this bell-shaped curve to it. Then the number is the mean, and the second number is the standard deviation. So we got through the first 2 examples here, and we sort of had left off with needing to do the third example. So now we're going to find what percent of Kentucky games they would score between 83 and 91 points. So just as before, I'm going to start with my picture. Let's remember we're centered at the mean, which was 75. And then I have that same standard deviation, so the numbers on my picture aren't going to be any different than they already were. So we had this as 67, 59, 51, 83, 91, and 99. And our goal is to find between 83 and 91. So our picture would look like that. Now, if you were looking at that second picture that we drew last time, this is going to be a pretty easy piece to find. So we already have that from before, so I'll pull that up here real quick as well. So right, if I had this picture, I can actually see pretty easily that it's going to be this 13.5% as my answer. But as I said in class on Wednesday, if all I remember are these 3 numbers, I should still be able to come up with my answer. So we're going to do it that way as well. So with what I talked about in class, let's focus on where these numbers are. Right? This is 1 standard deviation above the mean, which I kind of know is 68%. So what I do know is that between here and here is 68%. I'm sorry, my line didn't go straight up very well there. So I have that. And this one is 2 standard deviations. So what I also know is that between here and here is 95%. But just how we came up with that picture last time together, so where I'm going to start, right, I know that these 3 pieces have to add up to 95%. I've already put 68% on there. So I'm going to subtract that off, getting me left with my 27%. And then I have 2 different pieces that needs to go into. And so we're going to have to divide that by 2 to get our 13.5% to be here, as well as that piece that we were actually trying to find as well. So here then, just remember for completeness, we're going to always interpret this as well. So I can say that 13.5% of Kentucky games, they score between the 83 and 91 points. Now the 2 we did in class together, and this one we're going to talk about what the z-scores are, just to really kind of understand what's going on here. Right, so looking at just the example I just completed, we have our formula for our z. Right, I know for every single one that I did, the mean was 75, and the standard deviation is 8. Right, so that's the same each time. So if y happens to be 83, what do I get for my z? I get 1. If y happens to be 91, what do I get? I get 2. Now, why does this make sense? Remember, z measures the number of standard deviations we are from the mean, and we went up here, we went out in increments of the standard deviation. So if I go back up here and look at my picture, let me get a different color here to work with. I'll work with my purple here. So I can calculate the z for every single one of these numbers. I'm going to kind of work out, I'm going to erase this so you can see this a little bit better right now. I'm going to start in the middle. If I plug in 75 in for y, what am I going to get? I'm going to get 0, because I'm 0 standard deviations from the mean. We already saw for 83 we get 1. For 91 we get 2. What's going to happen if I plug in 99? I get 3. What if I plug in 67? Now I get a negative 1. Negative because we're below the mean, but I'm still just 1 standard deviation below the mean. Plug in the 59, I get a negative 2. And plug in the 51, I get a negative 3. Right, so hopefully you can see how this relates now to our z-scores that we've talked about already as well. So all the probabilities that we found were pretty easy because they fell perfectly on one of these increments that I had. But what if instead I wanted to find out the percent of games that they have more than 70 points? So if I drew my picture here, right, so where is 70? Kind of about right there. Right, and we would want, it says more than. So it would look like that. But I don't really have an easy way of coming up with that number. So let's figure out what we can do to help us then here. So I have some directions here on the page of how to calculate some probabilities. And the main reason why I have them is a lot of times when I'm doing this at first, it makes really good sense, but then when you're trying one on your own, you can't really remember the steps very well. So we'll kind of come back to these. And then we have some useful relationships between z-scores that we'll fill in as we need. So what we're actually going to start with is go ahead and start with looking at a problem and kind of going through those steps. So here we're working with women's heights. They're normally distributed with a mean of 65 and a standard deviation of 2.75. So again, same shorthand notation. So women's heights are distributed normally, mean, standard deviation. We're going to use this information to find the probability that a randomly selected woman is 63 inches or shorter. Now these pictures I was already pretty nice and gave you the little tick marks along the bottom. So let's start by putting the mean on there is 65. This time our standard deviation is 2.75. So as I move to the left, I'm subtract 2.75, subtract 2.75, subtract 2.75. So that one's 62 1/4. This one is 59 1/2. And then finally 56.75. Going in the opposite direction, we're going to add that 2.75 each time. Alright, so we've done sort of the first part of our directions that we see here. So I've graphed my bell-shaped curve. Now we're going to graph the value or values of interest relative to the mean. So basically what number shows up in the problem? 63. Where does it belong on my picture? It's somewhere over here. And then are we going to shade to the left of 63 or shade to the right of 63? Well, it says 63 inches or shorter. So shorter are going to be those to the left. Okay. So basically the first 3 steps are draw the appropriate picture. Our next step, as we have here in the directions, is that we're going to be defining the z value. So we know our formula for z is y minus mu over sigma. So we already know the mean is 65 and the standard deviation is 2.75. Y is just the number that shows up in the problem. So that's going to be our 63. Our mean is 65 and our standard deviation is 2.75. So we're going to get our z, and I'm always going to round these to 2 decimals, and I'll show you why as we go to the table. So I should get negative 0.73. Now we've already calculated a z before, so we shouldn't be surprised by this, right? It's negative because it fell below the mean. It's not quite 1 standard deviation below, so that's why it's smaller, sorry, technically or bigger, than -1, but it's not quite as negative as -1 is. All right, so up to here should feel good. The next thing we're going to do is actually be going to this table that I mentioned. So this is out on Blackboard. If you want to make sure you're looking at it with me, I'm going to pull it up here as well. So this is our table, and it's actually two-sided. The first thing you'll notice is the picture at the top. And the reason why I like this table is because of this picture. It's a nice reminder that whenever I look at this table, it's shaded to the left. Okay, so it's always shaded to the left. There are 2 different types of numbers that we have. So we have the numbers on the outside, which are your z-scores, which round to 2 decimal places. Let me make some notes of this for you as well up here. All right, so z is the row and column in the table. And it only has 2 decimals for it. So that's why I'm always going to see me round mine to 2. And then the other type of number we have are these inside numbers, which are actually the probabilities. So all these ones that have 4 decimal places that you see are probabilities. Okay. So how this is going to work with my problem. So I want to find basically being left of 63, or looking at my table, that would be being left of negative 0.73. So the first thing I like to ask is, does my picture match the table? So we're shaded left. As we see from the top here, the table is also shaded left. So we have a match, meaning I can come straight to my table to get my answer. Okay, so what we're going to look for is this negative 0.73, and it's a z. So up through the first decimal point tells me the row that we're going to go to. And the second decimal point tells me the column I'm going to go to. So we're going to take this number to the table. So negative 0.7 is going to be our row. The 3 is going to be our column. So here's our rows I'm looking for. I'm looking for negative 0.7, which is right here. My second decimal point tells me which column I'm going to go to. So this would be if it was the second decimal was 0, second decimal was 1, 2, and then 3. So this is the column that I want. So scrolling down in there, where those 2 numbers match up, I find 0.2327. So again, that's negative 0.7. And if we scroll to the top here, you see that that's the 3 column that we have there. So all I'm going to write right now is my table value is the 0.2327. Now, since our picture matches, that actually means then for us that the probability then really just is that 0.2327. So last, if we're going to interpret this, and let's see if this seems reasonable to us. So I can then say the probability that a randomly selected woman is 63 inches or shorter is, and you can either leave this as a decimal or if you prefer, you can actually change that to a percentage by multiplying by 100%. And so, 63 inches is about 5'3", so we're seeing about 23% of women are shorter than 5'3". It probably seems like a somewhat reasonable answer. Okay, let's look at B. So we're still talking about women's heights. So I'm first just going to go ahead and add all my numbers to the bottom because they're not going to be any different because I haven't changed the mean. I haven't changed the standard deviation. So none of those are going to change for me. But this time the number that shows up in the problem is 70. So where does 70 belong on my picture? Well, between these two numbers, it's a little bit closer, of course, to 70.5 here. I'll say about there is where my 70 falls. And then should I shade left or shade right? Well, it says 70 inches or taller. So for that reason, the taller part is going to tell me to shade to the right. Now I can already tell from my picture, again, what kind of z I'm going to have. Well, it's going to be positive because it's above the mean. More specifically, it's between 1 and 2 standard deviations above the mean. So I know I'm going to get a number between 1 and 2 when I do my z calculation here. So my z, this time the only thing that changes is my value of y, because this time it's the 70, but the mean is still 65. The standard deviation is still 2.75. And again, we're going to round this z to 2 decimal places, which is 1.82, which is between our 1 and 2, like I knew it was supposed to be. The first, up to that first decimal point, again, tells me my row that I go to. That second decimal point tells me my column I should go to in my z table. So here's my 1.8 as my row, my 2 as my column, so I get 0.9656. So far, so good. All right, now here's the problem. My picture is shaded to the right. The table is shaded to the left. So that number I just found really isn't my answer, but I can use it to help me find my answer. So what we're going to do is talk about on the previous page where you have some useful relationships of z-scores. All right, so in our example, which is what we're going to work with here, we have something where we're shaded to the right. Now we're talking about how we're going to do this. I want to talk about it conceptually here first. So conceptually, this is pretty easy for students to understand. So suppose you came in the first day of class and asked me what the chance is that you pass my class. And if I told you, well, about 15% of students do not pass my class, could you tell me what percent do pass? Right, so if 15% don't pass, that other 85% would pass. So how do we get that? Well, we're just taking 100% and subtracting off that 15% to get us left with that 85%. So I'm going to take the same idea here. So what I'm going to start with, picture-wise, is everything 100% or 1, and subtract off what I don't want. So basically I do 1 minus whatever I find in my table, that's actually going to give me what I do want. Or if I think about it picture-wise here, this 0.9656 that I got is actually telling me this piece, right? This is the 0.9656, because that's what's everything that's to the left of that number. So if I want to find just what's to the right of that number instead, I'm just going to take 1 minus that 0.9656, which will get me 0.0344, which also makes a lot more sense looking at my picture. But I can tell I don't have a lot of that picture shaded, so it should have been nowhere near 96% of that picture shaded. Alright, so how do I know when to use this rule? So I refer to this just like the picture says, if you're ever shaded right. So whenever you're shaded right, you're going to use this 1 minus rule. Alright, so then all we're left with here is the interpretation. So then I can say that the probability that a randomly selected woman is 70 inches or taller, which is 5'10". So we know there's not probably a ton of women out there that are taller than 5'10", is 0.0344, or again, if you prefer percentages, multiplying by 100% would get us 3.44%. Okay, another example. Suppose we want to find the probability a randomly selected woman is between 63 and 69 inches tall. So I'm still working with women's height, so I'm going to have all those same numbers along the bottom. So I'm just going to put those in here real quick. Now I'm going to find between 63 and 69 inches. Alright, so 63 is about there. 69 is about there. And we want between. So that would be our picture that would go along with the problem. Alright, now our next step has been to find z. But now actually this time I have 2 z's I need to worry about finding. So I have a 69 for a y and I have a 63 for a y. So let's do it for the 69 first. So y will be 69, the mean was 65, my standard deviation was 2.75, so that's going to give me a z of 1.45. I'm going to do the same thing with my other z. So my y is 63 for that one. Mean is still 65. Standard deviation is still 2.75. Giving me a z of negative 0.73. Okay. Now if we compare this to either of the ones we've done so far, first one was shaded left, second one was shaded right. This one fits neither of those cases. I'm shaded between 2 things. So we're actually going to talk about what we're going to do before we do it. So this is actually rule number 2, which I would refer to as the between rule. So I'll start with my picture. And it doesn't matter where you are on this picture, as long as you're shaded between. I'm just going to sort of generically label these points A and B along the bottom. And this will be our between rule. Now what I'm going to do is based upon the actual table. So the table is shaded to the left. So I have to work in things that are shaded to the left. So I'm going to start by taking everything that's to the left of B. And if I compare that to what I want, I have too much, right? I don't want this piece. I only want everything from left of B to here. So I have too much. Hence why we're going to subtract something off. Now what do I want to subtract? Well, I want to subtract off everything that's to the left of A. So really what that means I'm going to do here is I'm going to find my table value. for B and subtract off my table value for A. So what does that mean we're going to do for ours? Well, I'm going to take my two z-scores that I just found, and we're going to take them to the table. So we're just going to have to go to the table twice. So we're going to look up this 1.45. Remember, the first one's row, second one is column. So positive 1.45. So here's our 1.4, and our 5 column gets us this 0.9265 for that one. We're going to go to the table with our negative 0.73, so that's our row. That's our column. So I got to go to the negative side this time. So here's our negative 0.7, and then our 3 column is actually the 4th column there. So it's the 0.2327. So then to actually find my probability, just like I taught myself here with that rule, so I'm going to take the 1 probability, the higher one, minus the lower one, to get me 0.6938. So then again, last, if I want to do this, I want to interpret it as well. So I can say the probability that a randomly selected woman is between 63 and 69 inches tall. Is our 0.6938, or again, if you prefer, 69.38%. Right, so we've seen an example of each. So we've seen one that's shaded left, we've seen one that's shaded right, and we've seen one that's shaded between. Using all of these concepts, I can really now find any probability that you ask me to find. So the rest of this video is just doing another practice. If you feel like you're very comfortable with what we've done so far, and you want to see if you really are, you can always pause the video here and work the problems yourself and then see if they match. If you're still feeling uncomfortable, go ahead and just stick along with me as we work the problems. But again, if you feel pretty good, go ahead and pause it here and give it a chance. Alright, so for our new example, we're looking at house values in a certain town. They're relatively normal with a mean of 156,000. So that's going to be our mean. And a standard deviation of 23,600. So that's going to be our sigma. Okay. Our first question is to find the probability a randomly selected house in this town has a value that is less than 190,000. Alright, so we're going to start with the picture. Alright, so just as before, I'm going to start by putting the mean on here, as well as going out my 3 standard deviations. So my mean was 156,000. And as I go to the left here, I'm going to subtract 23,600, subtract 23,600, and keep doing that as I go. So I get 132,400 the first time I subtract, 108,800 the second time I subtract, and then 85,200 the third time I subtract. In the opposite direction, we're just going to add the 23,600 each time. So I get 179,600 the first time I add, 203,200 the second time I add, and then finally 226,800 the last time. So just starting with my picture there. Now it asks us to find with 190,000. So where is that on my picture? Well, that's at least between the 179 and the 203. So I'm just going to place that on there. Okay. And then I've got to ask myself, am I going to be shading left or shading right? And it says less than 190,000. So for that reason, we're going to shade to the left. Okay, our next part is to find our z. Using the same formula, we just have some different numbers compared to before. So the y is one that shows up in the problem. So we have 190,000. Subtract off our mean of 156,000 and divide by our standard deviation of 23,600. That should give us a z-score of 1.44. Now usually at this point I ask you to think of a couple of things already. Let's go ahead and think, right? Our z makes sense because we're between 1 and 2 standard deviations above the mean. Above is why it's positive. It's between 1 and 2, just like I can see on my picture. I also know my answer is going to be bigger than 50% because everything to the left of 156,000 would be 50%. So I know my answer should be more. Finally, I know if I need to use a rule on my problem. My rule doesn't need to be used here because my table is shaded left as well as my picture is shaded left. So we're actually going to get to go straight to the table with our z here and get our answer. So remember, row, column. So we go to our table, positive side this time, and we find our 1.44, and we find a 0.9251. And again, as we just discussed, our picture is shaded left, the table is shaded left, so that number that we just found in our table actually is our probability. So then we can go ahead and interpret here. So the probability that a randomly selected house in this town, and we're basically repeating the question with an answer, has a value that is less than $190,000 is 0.9251, or again if you prefer, 92.51%. I hope the math is feeling okay. How this could be useful for someone is if I'm looking in this town and my budget, the highest I'm willing to go is $190,000. I have a pretty good chance of finding a house in this area, right? There's 92.5% of the houses basically should be in my price range. So I kind of know that before I keep going. All right, next question. We're still working with house prices. I'm actually going to just go ahead and draw my picture because it's not going to change compared to where we just were with part A. So the mean is still 156,000. The standard deviation is still our $23,600. So none of my numbers along the bottom are going to change here. But this time it asked me to find a value that's more than 140,000. So about roughly, here's my 140,000. And this time it does say more than, so I'm going to shade to the right. Now looking at my picture, again, things I'm going to already know. One, I know my z is going to be negative because it's below the mean. More specifically, it's going to be between 0 and -1. I can also tell you my answer is going to be bigger than 50%, because if I just had everything to the right of 156 shaded, that would be half, because we're symmetric about the mean. And then finally, I know I'm going to use the 1 minus rule because my picture is shaded right. So whenever my picture is shaded right, I have to do that 1 minus rule. But of course, our next step here is going to be doing the z. So this time, the only that changes is the value of y is $140,000. The mean is still 156,000. Standard deviation is still 23,600. So this time we get a z of negative 0.68. Just like I thought, it's between that -1 and 0. So again, that first decimal point is our row, second decimal point is our column. So we're going to go to the table. This time the negative side. And here's my negative 0.6 row. Got to find that 8 column. Let's see, it's the second to last column here. So it's going to be this 0.2483 that I see. But again, that number I just found, as the picture tells me on the table, that's actually what's to the left of the number I just found, not what's to the right. So because of that here, I have to use that shaded right rule, or the 1 minus rule, and take 1 minus the value I just found in the table. And again, I knew my answer had to be bigger than 50%. I could tell you that from my picture. Alright, so last, interpreting. So we can then say the probability that a randomly selected house in this town has a value that is more than 140,000 is our 0.7517, or prefer again the percentage to be 75.17%. Alright, last example, still working with house prices. So again, I'm just going to start with my picture. And I don't like how that wasn't really in the middle very well there. There we go. All the same numbers along the bottom. And this time we're asked to find between 135,000 and 185,000. So let's see, 135,000, I'll say is about here. And that's my 5. Just erase that. There we go. And our 185. And we want between. Alright, so what I can tell from my picture, so one of my z's will be negative since it's below the mean, one will be positive. This one will be between -1 and 0. This one will be between 1 and 2. I can also tell you I need to use the between rule since we're shaded between. So our next step is to find both of our z's. And again, I need to start with the higher one. So I'm going to do the 185,000. Same mean, same standard deviation, and we get 1.23. which is between the 1 and 2, like I knew it should be. Doing the same thing with my 135,000. I get negative 0.89. So now we're going to take both of these numbers to the table. And see what we get. So for the positive 1.23, so there's our 1.2 row. The 3 column gets us the 0.8907. And now going to the table with that negative 0.89. So notice the 9 is the last column there. So here's our negative 0.8. And we get 0.1867. So the between rule tells me then to subtract those probabilities. Remember, a probability always has to be a positive number, so if you subtract them in the wrong order and you get a negative number, just remember then to flip your order of subtraction here. So we should get 0.7040 after implementing the between rule. So then last, of course, we will interpret it. So then I can say the probability that a randomly selected house in this town have a value that is between 135,000 and $185,000 is 0.7040 or 70.4%. So that's where we'll leave class for today. You can probably already start looking at the practice homework that's out on Blackboard. Please note you actually can't do all of it yet. If you see anything that says like a cutoff value or a percentage, those are ones to wait on until after Wednesday's class.